All right, y'all go ahead and do the factoring in the math knowledge question, pause the video, and then once everyone is finished, you can unpause the video, and I'll show you the correct answers. So this factoring is basically just a sum of two cubes, so you're going to use your formula. So we're going to have 2a plus 5, and then 4a squared minus 10a plus 25. And so that is your answer for your factoring question. For the math knowledge question, we've got tables that are $40 for large ones and $25 for small ones. So we want to know how much is it to rent all the small ones. Well, they're $25 and we've got 50 of them. And then L of the large ones. Well, that's $40 times L. 25 times 50 is 1,250, and then plus 40L, that's going to give you B for your answer. Okay, so we are looking at Pascal's triangle, dealing with binomial expansions on lesson 77. So hopefully you'll understand how to do binomial expansions after this lesson. So to do a binomial expansion, you're going to use Pascal's triangle. These are all examples of binomials. This first one, f plus s squared, you know how to expand that pretty quickly in your head. Now the 1 to the 7th, the 5th, or the 4th, you're going to have to do a little bit more work to expand those. But using Pascal's triangle, it'll make it a lot quicker. Okay, so we're going to actually develop Pascal's triangle here. So I want you to go ahead and write down a plus b to the 0, a plus b to the 1st, all the way to the 6th. And so we're going to actually expand it, and hopefully you'll see Pascal's triangle once we get finished. So a plus b to the 0, anything to the 0 is a 1. So we're going to just put a 1 here. And we want to put it in the middle so that our triangle won't get squished. Now we're going to have a plus b to the 1. Well, that's just going to be a plus b. For the next one, a plus b squared, you're going to have a squared plus 2ab, and then plus b squared. For the next one, we're going to actually multiply. I'm going to come down here and do it. But we're going to multiply a plus b times our a plus b squared, which was a squared plus 2ab plus b squared. So we're going to distribute. And then ab squared. And then a squared b plus 2ab squared. And then plus b cubed. So if you add those, you have a cubed. We have a 2a squared b and an a squared b, so that's 3a squared b. Then we have ab squared and 2ab squared, so 3ab squared, and then plus b cubed. So I'm going to write that in my next line. A cubed plus 3a squared b plus 3ab squared plus b cubed. And I want you to actually be writing all this out in your notes, because hopefully when we get done, you'll be able to see Pascal's triangle. So now, to do to the 4th, we're going to take this part and multiply it by a plus b. So if we multiply it, we're going to have a to the 4th plus 3a cubed b plus 3a squared b squared, and then plus ab cubed, and then plus a cubed b plus 3a squared b squared plus 3ab cubed, and then plus b to the 4th. So if we combine those terms that are like, we have a to the 4th plus we have 3a cubed b, and we have another a cubed b, so we have 4a cubed b. Then we have 3a squared b squared, and we have 3a squared b squared, so 6a squared b squared. We have 1ab cubed and 3ab cubed, so 4ab cubed, and then plus b to the 4th. So we're going to write that as the next line. A to the 4th plus 4a cubed b plus 6a squared b squared, and then plus 4ab cubed, and then plus b to the 4th. Okay? So now for the a plus b to the 5th, we're going to have to do that same thing again. So we're going to multiply this by a plus b. So we're going to have a to the 5th, and then 4a to the 4th b, and then 6a cubed b squared, and then 4a squared b cubed, and then we'll have plus a b to the 4th, and then a to the 4th b, 4a cubed b squared, 6a squared b cubed, 4a b to the 4th, and then we have b to the 5th from this last one here. So now we can combine our like terms. We have a to the 5th. We've got 4a to the 4th b and a to the 4th b. So that's 5a to the 4th b. We have 6a cubed b squared and 4. So that makes 10a cubed b squared. We have 4a squared b cubed and 6 more. So that's another 10a squared b cubed. Then we have a b to the 4th and 4 more to give us 5a b to the 4th and then plus b to the 5th. So now we're going to write that as our next line. Okay, and we've got one more line to do, and then hopefully you'll be able to see the pattern. Okay, so we're going to multiply all of this by a plus b. And I'm not going to just use my distribution lines because it's starting to get a little hectic because I've got so many of them. But I'm going to have a to the 6th, and then 5a to the 5th b, and then 10a to the 4th b squared, and then 10a cubed b cubed, and then 5a squared b to the 4th plus a b to the 5th. And then I'm going to come down here, and I'm going to have a to the 5th b, 5a to the 4th b squared, 10a cubed b cubed, 10a squared b to the 4th, 5a b to the 5th, and then b to the 6th. And so if you combine your like terms here, I wrote them so that they're kind of below each other. You'll have a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6a b to the 6th and then plus b to the 6th. And so we're going to write that as our last line. A to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a to the 3rd b cubed plus 15a squared b to the 4th plus 6a b to the 5th and then plus b to the 6th. So that is part of it. We could obviously just go on and on and on forever and ever. But Pascal's triangle, it helps us with the coefficients. We've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And then we have 1, 6, 15, 20, 15, 6, and 1. Do you notice how they are symmetrical? Does anyone know possibly what the next line of coefficients would be? I'll give you a second to think about it. You can pause the video if you want. Okay, I'm about to tell you what they would be. It'd be 1, 7, 21, 35, 35, 21, 7, and 1. I hope maybe someone in here got it right. The way you get it, you add the two above it. So 1 plus 6 is 7. 6 plus 15 is 21. 15 and 20, 35. 15 and 20, 35. For this 6, you would have done 3 plus 3. For this 5, you did 1 plus 4. For this 2, you did 1 plus 1. For this 1, there's only 1 above it. There's nothing here, so that's why it's a 1. Hopefully that makes a little bit of sense there. For the exponents, in your term, whatever this number is here, your exponents are always going to add up to that. So I'm going to use a red. This is a squared. We've got a 1 and a 1. Those add up to 2, and that adds up to 2. Let's get down to the 4. Those add up, well, it's just a 4. 3 plus 1 is 4. 2 plus 2, 1 plus 3, and then 4. They always add up to the exponent that they give you right here. So this is a 6. So we'll have 6, 5 and 1 is 6, 4 and 2 is 6, 3 and 3, 2 and 4, 5 and 1, and then a 6. Okay? So using Pascal's triangle, that is how we're going to actually expand these. So let's look here. We want to write the 4th term of x plus y to the 6th. So what we need to do is to start by doing our Pascal's triangle. But when you do Pascal's triangle, you only do the coefficients. You don't put all the variables in there. So we're going to start with 1, and then the next line is going to be 1, 1, and then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. And we are on the 1st, 2nd, 3rd, 4th, 5th, and 6th line. But this is only x plus y to the 5th, because this one up here was to the 0. So we've got to go one more line. And so now we want the 4th term. Well, this is the 1st, the 2nd, the 3rd, and the 4th. So we know that it's going to be 20, and we're going to have an x and a y. On this term, it was x to the 6th, and then x to the 5th, x to the 4th, and so this one is x to the 3rd. So we have x to the 3rd, and then our y, well, what is going to add up to 6 if we have a 3 here? That one's going to also have to be a 3. And so the 4th term would be 20x to the 3rd y cubed. And that would be your answer there. And if you go back over here to Pascal's triangle, our 4th term was 20a cubed b cubed. We just have x and y instead of a and b. Okay? Now we want to write out all 8 terms of the expansion of x plus y to the 7th. So we first need to start with our Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Whoops. That's a 15. And so if I go to 1, 7, 21, 35, 35, 21, 7, and 1, that gives me all of the coefficients. Okay? So we're going to have 1 x to the 7th, because that's what our exponent is, and then plus 7. Our x is going to drop by 1 so that our y can go up by 1. It was a 0 on this first term, so now we have a 1. And then we go to 21 x to the 5th. Well, our y has to go up to a 2 because it has to always add up to 7. 35 x to the 4th y cubed. Another 35. We've got 2 35s here. So 35 x to the 3rd y to the 4th. 21 x squared y to the 5th. 7 x y to the 6th. And then 1 y to the 7th. And so that would be how you would use Pascal's triangle to actually expand it. Okay, so you don't have to use it. You could do all of the work like what we were doing to start with. But it's kind of easy to make a mistake when you're doing all of that by yourself. So I recommend doing Pascal's triangle. You will have to recreate this on your test. So if you want to keep flipping back in your notes just to make sure you understand it to start with, you can. But you're going to have to be able to recreate it all by yourself on your test. So hopefully that helps you a little bit with binomial expansions. We'll look at binomial expansions again later in the year, but this is just the basic concept with Pascal's triangles. So make sure that you do your homework 1 through 30 tonight so that we can go over any questions you have tomorrow.